Hello everybody and welcome to Chapter 1, Lesson 1, Absolute Value Functions. Our essential question is how do the values of a, h, and k affect the graph of the absolute value function g of x is equal to a absolute value of x minus h plus k. What you will learn is how to graph an absolute value function in vertex form and how to write a function for an absolute value graph. An absolute value function is a function that contains an absolute value expression. So those two little vertical lines. The parent absolute value function is f of x is equal to the absolute value of x and the graph of this function, as I'm going to show you here once I press submit and I typed in my function, is a V shape. It is a V shape, and that is symmetric off the y-axis. The vertex is the point where the graph changes direction. So if we see here, our graph is changing direction. It's coming from left to right. We're coming down on a decreasing slope. We hit this point right here, which is called the vertex, and then we change direction and we start going up at a positive slope. Okay, and the reason for this is because our absolute value symbol creates this shape because it makes whatever value is in here a positive, right? And we see that this graph does not go below the x-axis into the negative values. If I were to change and take away our absolute value bars, we will see that we actually get a diagonal line across 0 at our origin. So by adding our absolute value, we're actually getting rid of this bottom piece of the function and we're moving it up. So by adding our absolute value, we then make that part of the line positive per se, and it creates a V shape. Example number 1 is graphing an absolute value function. So here I have a function g of x is equal to 2 absolute value of x plus 1 minus 4. So I'm going to go ahead and write that right here because we're going to break down our function. So this is our function. So our vertex form is the function without numbers, just I'm going to use variables, x minus h plus k. So this is our vertex form in black. This is our function that we're graphing in blue. So in order to graph our function, the first thing we're going to need to do is find our vertex. The vertex is located at the coordinate h, comma, k. So we're going to go ahead and take a look at both of these functions. One, we're going to look at vertex form. This is the function that we kind of guide ourselves with. And then we're going to compare that to the graph we're supposed to graph. So to find the vertex, which remember is this little point right here, that's what we're trying to look for. Okay, we're going to identify the value of h. So I'm going to go ahead and circle this section right here. And notice how I have a plus 1 in the same place where the h would go in our function. So that's the number that I would put for my coordinate. But notice how I have this is negative h. So because our vertex form in black has a negative sign here, that means we're going to take this number here as the opposite value, the inverse, because that is what this negative sign is telling us to do. It's taking the opposite. So instead of writing a 1, positive 1 for h, we're actually going to write a negative 1 for h. Okay, and this is the most important part. This is the part where most people get tripped up when graphing, is that the h value inside is actually the opposite. The k value, on the other hand, is exactly as it's written. It says plus k, so look at the plus k is in the same position as the 4, the negative 4. So because we have a positive, that's okay. We're going to just take this value just as it is. So it's a -4. So the only one that is the opposite is whatever is in this position here. If this was a -1, for example, if it was a -1, I would take it as the opposite. I would have written it as a positive over here. But because it was positive, we're going to take it as the opposite, which is negative. K stays the same. All right, so then what I'm going to do is I'm going to go ahead and plot that vertex onto my graph. So I have -1, -4. So I would plot a point at -1, -4. Okay, just right there. That's my vertex. Okay, I'm going to go ahead and label that so you guys know. And I'm using the same colors kind of just to help you guys kind of see where everything is going. All right, perfect. And now what we're going to do is we're actually going to use our last value, which is A. A is basically the slope of our absolute value function. So it determines how wide or narrow our graph is. If it looks like you're stretching, kind of like your arms, you're stretching them, and you're stretching as far as you can, that's going to change the slope. Or it kind of looks like they're lower, which is a shrink. So our A value is equal to 2. So we're going to take this as our slope. Okay, so in order for us to have a slope, I have to have a fraction. But because this is not a fraction, I'm going to go ahead and just put that over a 1. All right, this is my rise over run. Okay, so my graph here, I'm going to take this point and I'm going to go from this orange point here, the vertex, I'm going to count up 2 squares and over 1. And I'm going to place a point there. So I'm going to use green as my color. So this is going to go here, right? I went up 2 squares to the right 1. And I can keep on going to kind of get a shape, right? And if this were a linear function, I would do the opposite way. So I would go left 1, down, or down 2, left 1 to create a line, right? I would do this if this was a linear function. Unfortunately, this is not a linear function. We need it to be a V shape. Okay, so what we're going to do is I'm going to go up 2, and instead of going to the right again, I'm going to go to the left. So I'll have another point here because this function is symmetric, right? It's the same on the left of the vertex. Let me draw this line right here real quick. If I draw a line through the vertex, everything on the right side is going to be the same squares away from that line as on the left side. So I'm going to have another point here and another point here. Each is the same amount of squares away from the middle line. So 1, 2, 3, 1, 2, 3. All right. So now I'm going to connect all of my points. I can kind of see my V shape, so I can go ahead and graph it from here. And I can see my V shape is going this way. We need it to be a perfect V shape, symmetrical V shape. So I'm going to use my straight line tool to draw my function. So the graph of the absolute value function to absolute value of x plus 1 minus 4 is this in black. Now, there is one difference when you get further onto the problems. If your A value here was a negative, instead of going up 2, you would go down. So then your graph would actually be upside down. It'd be a V shape upside down. So it looks something like this in red. Okay, so when it's negative, then it's going to be basically an upside down V. So we want to be very careful with whatever value A is. If A is positive, it's a normal V shape facing up. And if it's a negative value, it's going to be a V shape facing down. It's a reflection across the x-axis. All right, we're going to go ahead and move on to example number 2, which is also graphing an absolute value function. But in this case, we're missing a bunch of stuff from here. All right, so here is our function, and here is what we're doing, right? This is the function. But there's missing parts, right? Inside the absolute value, there's nothing here. There's nothing that represents h. Okay, so if there's nothing there for h or for k, if in the future you'll see, then what that means is that it represents 0. So inside of our function, we actually have something that says x plus 0. It's just not written there. We never write plus 0 for anything. But because there's nothing there for h, we're actually just going to kind of fill that in right there. And then also, we don't have an a value, right? There's nothing for a. So this is kind of just like writing x. If there's nothing in front of the variable, we always assume that there's a 1 there. Okay, so for this, our a is actually a 1, not a 0. Just because there's nothing there doesn't mean that it is a 0. It is actually a 1 for a. So our full function here is 1 absolute value of x plus 0 plus 3. Okay, and then we're going to do this the same exact way as the example number 1. We're going to find our vertex. Our vertex is h comma k, right? They're in the same positions. The number inside the absolute value is h. So we have 0 comma k. K is a positive 3. So our vertex is located at 0, 3. 0 on the x-axis, 3 on the y-axis. And then I'm going to use my a value, which is a 1. So a is 1. And remember, this is our slope. So I'm going to put it over 1. It is positive, so I should have a V shape open up, not a V shape open down. All right. So I'm going to go up 1 over 1, up 1 over 1. And I can do that the opposite way as well, up 1, left 1, because I need to have that V shape. It has to be symmetric on both sides. All right, and then I can connect my points using my straight line tool. That was a little crooked there. And this is the graph of the function of the absolute value when there's missing values like h and k. We fill in the place of h and k with 0. If there is no a, we replace that with a 1. Okay. Example 3, there's a typo here. Example 3 is writing a function for an absolute value graph. So this, we're going to do the opposite. We have the graph here. What we need to do is we need to figure out what is the function. Okay, we need to type out the function. So I'm going to go ahead and fill this bar right here with our parent function, with our vertex form, a absolute value x minus h plus k. And then I'm going to slowly start to replace the letters, the variables, with numbers to have our function. So if we remember from our previous examples, our vertex is a representation of the values of h and k. Okay, so we're going to look for our vertex. So our vertex is located here, and we're going to write the coordinates to that point. The coordinates to this point are 3, 5. So that means that h is equal to 3 and k is equal to 5. So I'm going to replace just the h, not the sign. I'm not going to change the sign. I'm going to say that's a 3. I'm going to replace the k with a 5. And we're almost done with our function. The next thing we have to do is change the value of a. So for a, remember that a is the slope of our graph. So I'm going to start at my vertex. I'm going to find another point. I'm going to say this point right here, or this point. And I'm going to see what my slope is. So I'm going to say down 1, 2. So remember, it's rise over run. So I have rise of 2, run of 3. 1, 2 over 3. Same thing on the left side. I can go down 2 over 1, 2, 3 to get to that point. Down 2 over 3. So 2 over 3 is our slope or our A value. Now we just have to determine if this is positive or negative 2 over 3. If our graph was open up like a regular V, that means that A is positive. If our graph, like this case, is open down, upside down V, then that means that A is negative. So our A value is negative 2 over 3. So I'm going to replace my A with negative 2 over 3. And this is the function for the graph of the absolute value in red. All right, so each value of the function in vertex form changes the graph in a certain way, right? So if we think about it, the one we've talked about is A. So A, right, changes the slope, so it makes it kind of more narrow or stretched out, or shrinks down. It's kind of like wider. If it's a negative number, then it reflects across the x-axis. It goes upside down. Right? And we haven't talked about what changes with H and K, other than it is the location of the vertex. So the vertex is this black point right there. So if I change the value of H, that moves the graph left and right. It's our horizontal shift. So remember that H is the first value of the vertex, right? And our vertex is HK. H represents X, so of course it makes sense that it's going to change left and right because that's our x-axis that goes left and right. Our y value, our k value, represents the y in the vertex. So obviously it's going to represent our change in location for y, which runs up and down. Okay, so that piece also makes sense. So this is what the values of A, H, and K do. H is a horizontal shift. K is a vertical shift. A changes the slope. If positive, the bigger the number, the more stretched out the graph looks. The smaller the number, the more shrunk it is. A negative value reflects the absolute value to be an upside down V shape. So it's a reflection across the x-axis. That is the end of our lesson. You should have learned about absolute value functions and how to graph them and how to write them, as well as finding out what the values of H, K, and A do to the graph. If you have any questions, please put them in the comment section down below. Thanks for watching, and I'll see you next time.